Okay, now let us start solving the third question of chapter 4 from Zettili. So in this we are given an electron with some kinetic energy 10 electron volt, and it hits a step potential having the potential of 20 electron volts. So first we have to find the time independent Schrodinger equations in two different regions, where one region is like a free particle region and in the other region the particle is facing some kind of potential, and we have to then figure out what would be the shape of such like waves of electron. So, and in the third question we have to calculate the wavelength of this electron, and then we have to write the boundary conditions for the particle at x equals to 0. So the movement would be something like this. So we have to find the boundary conditions over here, and the ratio of probability at x very like 10 to the minus 10. What would be the probability of finding electron over here and at 0? Alright, so I think I have pretty much explained the question. And now one thing which I would also suggest, which I would always suggest, that when such quantities are given like 10 volt and 20 volt, so rather avoid putting those values in the answer since the start. Just let's take the given values into some general variable, and then at the end when we want to like calculate, we'll just put the values. And I think that's process works really well for me, and most of my colleagues work the same way, and it gives a better insight on how things are working. Okay, so kinetic energy of electron is given to be E naught, so that is 10 eV, and the step potential 20 eV, we are taking it to be V naught. And please pardon me for the voice, it's kind of festival season around here. So moving on to the first question. So before we go on to put what is the answer for the first question, first let us put the general time independent Schrodinger equation, and that's nothing but minus h cut square by 2m, then second derivative of psi x by dx square plus v of x into psi of x equals to some energy into psi of x. Okay, now for x less than equal to 0, my v of x is 0 and my e is a constant e naught. That would be minus h cut square by 2m d square psi by dx square plus 0 equals to e naught psi. Alright, so this is my one Schrodinger equation, and for greater than 0 it would become minus h cut square by 2m d square psi by dx square plus v naught into psi. V of x is v naught, so it's a like for x equals to 0, it's constant potential from 0 to infinity, rather like to mention that, and e naught psi. Alright, so this is the Schrodinger time independent equation in the region x than 0. So these are the two things. So I think we have covered the first question. That's done. Now we'll move on to the second one, which says that describe the shapes for psi of x less than 0 and greater than 0. So basically it's been asked that we have to solve this, or rather work our way through the general solution of these two equations and describe how the solution might look. So for the first one, where it's given that minus h cut square by 2m d square psi by dx square equals to e naught psi, it would look something like this. If I transform d square by dx square plus 2m e naught by h cut square psi equals to 0. And now if I put it as k1 as 2m e naught by h cut square, then my equation becomes d square psi by dx square plus k1 square psi equals to 0. And we know the general solution of such kind of equations, and that would give me psi 1. And since it's in the x less than 0 state, so I'm just putting it as psi 1, and psi 1 is nothing but a e to the power I k1x plus b e to the power minus I k1x for x less than 0. Okay, so this is something this is some kind of a general solution for second order differential equations of such kind of form. Now we move on to the case, this is for x less than equal to 0, and now we move on to x greater than 0, and the equation with in our hand is minus h cut square by 2m d square psi by dx square. Sorry for the handwriting over here. Plus v naught psi equals to e naught psi. Alright, now d square psi by dx square plus 2m v naught minus e naught upon h cut square. Okay, so over here I have made a mistake, and this is the rectification, equals to 0, and there's a psi over here. Now if I put this as gamma as 2m, gamma square as 2m v naught minus e naught by h cut square, then this becomes, and this would become d square psi by dx square minus gamma square psi equals to 0. And the general solution for such kind of equations that we know are, let me call this as psi 2 since it's in the other region, and it would be e to the power minus gamma x plus d e to the power plus gamma x. Alright, now this equation signifies that it's an exponential on the negative side, but it's not possible in the form of in the case of step potential, so this reduces to 0. Alright, wait, I have once again made a blunder over here, I would say. So yeah, we have now psi 2 finally, which can be written as psi 2. Wait, I made a mistake over here. For a acceptable solution, I must have this term to be 0. Okay, so my psi 2 becomes c e to the power minus gamma x, and gamma here is a real quantity, so my psi 1 from the previous page I can say psi 1 is a e to the power I kx k1x plus b e to the power minus I k1x, and psi 2 equals to c e to the power minus gamma x. Alright, now this is an oscillatory solution, it's an oscillatory form, and this is a decaying form of wave function. So wave function would something in a very rough, with a very rough plot, wave function would look something like this. Now in this, and this is 0, this is psi versus x. I guess you get the idea where the wave function is like oscillating in the left region, and on the right region it's kind of decaying. Yeah, okay, then I guess we are completed with the 2 questions, and now let's move on to the third one, wherein we are asked to calculate the wavelength. So over here we will once again use the de Broglie wavelength formula. So de Broglie wavelength is lambda equals to h by p. So for x less than equal to 0, p is under root 2me naught, which implies my lambda 1 will be, this is my p1, lambda 1 will be h by under root 2m e naught, and for x greater than 0, my p2 will be under root 2m v naught minus e naught. Alright, and that would give me lambda 2h by under root 2m v naught minus e naught. Alright, I guess you get the rough idea again. So over here I won't like go into putting the values of these lambda and like move ahead with it, but you can go ahead and put the values of e naught and v naught to get the values of lambda 1 and lambda 2. So yeah, when we are completed with part B, now let's move on to part C and write down the boundary conditions at x equals to 0. So the first boundary condition would be the psi is continuous at x equal to 0. So that would give me that psi 1 at x equals to 0 is equal to my psi 2 at x equals to 0. Alright, and that gives me a plus b equals to c. Yeah, and my second one goes like d by dx of psi 1 at x equals to 0 is equal to d by dx of psi 2 at x equals to 0, and that gives me ik1 a minus b equals to minus gamma c. Okay, now this is my equation 1, this is my equation 2. Solving 1 and 2, we can further get the values of a and like b and c in terms of a. So these are like the two boundary conditions 1 and 2, and the results of these two boundary conditions are the equations 1 and 2. Alright, now let's move on to the last question, wherein we have to calculate the ratio of probabilities of finding the electron near x equals to 10 to the power minus 10 and x equals to 0. So note, this is the ratio of probabilities. It's not like calculating two different probabilities at two different positions. Alright, so we have to calculate a ratio of probabilities. Okay, we'll move ahead in this form. And for the fifth question, I am myself pretty confused on how to proceed. So in that case, I would just say that if any one of you watching the video like knows the solution, do comment and let me know, because that's also something I need to figure out. Since I am a student, I am pretty confused. I might ask this to my prof, and again, or like write in comment if I get the answer or a way to move ahead or proceed with the answer. Yeah, so I guess that's it for the solution of third question. Thank you.